Hello and welcome to my CCNP version 8 Enterprise Core Networking lecture review. My name is Arthur Solomon and I'm going to be providing you lecture material for the ENCOR 350-401 exam. So this is going to be several video lectures covering the individual modules or lessons for the CCNP material. So let's jump in and let's see what we can do. Chapter 19, Understanding Wireless Roaming and Location Services. So you're going to notice we've spent a good amount of time talking about wireless technology, and that is because, well, users use it. But more importantly, it's often not really deployed correctly. One of the big areas that I see quite often not deployed correctly are the roaming services. Meaning when a user goes from one access point to another, it's normally not seamless. Or my favorite, you're at a enterprise, a large hotel chain, or some type of system event, and they literally have, hotel Wi-Fi 1, hotel Wi-Fi 2, hotel Wi-Fi 3, and then you just connect to whichever access point is the closest one to you. I've stayed at a number of hotels where they have that, and that's just real bad deployment. Where the larger properties like a Hilton or a Marriott, they have a seamless hotel Wi-Fi. And the nice thing is they also integrate other items like their reservation. That way there's an automatic billing and term of service that's already integrated within their wireless LAN controller. That all works seamlessly together. So when you deploy a wireless network correctly, everything just works the way it's supposed to. And that's a benefit. So in this chapter, we're focusing on three main things: roaming and locating devices within the wireless network. Roaming is going to be an overview of roaming as well as roaming between the centralized based controllers. So let's go ahead and let's jump right on in. Roaming overview. Basically, to understand how wireless roaming works, we're going to start with a very simple scenario with no controller and build from there. Here we have two access points where we have SID staff for both access points. And the nice thing is you're going to see there is some bleed over between the two networks. So this is going to be bleed over. Now in reality, both networks are still going. It's just these are going to be the spheres where they have the highest signal strength. So don't think that wireless just stops, like it keeps going. The interesting part is client 1 is attached to AP1. So the wireless client is associated and authenticated against that WAP. Before using the WAP's BSS to access the network, the client can also move to one of the other BSSs by moving. So if the client was over here, then it can connect to AP2. But they're not. They're attached to an area closer to AP1, so that's where the connection actually is. The client actively scans the channels and sends, this is the important part, a probe requests to discover what access points are there. So when client 1 first comes online, it actually could be receiving information between both access points. AP1 should come back with a stronger signal and less delay, so that's the access point that client 1 should connect to. However, client 1 could also receive stuff back from AP2, but with a much longer delay. So while it is discovered, it may not be the primary WAP that client 1 actually connects to. Again, the client will select the appropriate one as whatever criteria that they typically have. Normally, it's going to be a delay, distance, and load, but you can configure it for other areas as well. Now let's look at that a little bit more deeper. So here we have client 1 moving over to the client 2, the access point. So the client begins again moving around, walking around, and they're now in range of AP2 and a lot further away from AP1. So the client will decide the signal from AP1 has degraded to the point where it's no longer feasible, so it jumps over to AP2. The client will decide to roam and reassociate with AP2. So again, the important question here is the handoff seamless? Does AP2 know about all the sessions? Or if they're in the process of streaming a video, for example, if they go from one access point to another access point, does this stream still stay on? So that's one of the questions you have to ask yourself is, to what degree is the connection going to stay there? So successful roaming from a mobile client means that they should be able to go from one access point to another without the sessions dropping, without any information having to be reloaded. Each cell or each access point should be able to maintain the connection and softly hand off the client at the edge of each of their boundaries. So there are some other things to consider. For example, here we have an intra-controller roaming. Again, within our WAPs, they are bound to a wireless LAN controller through the CAP-WAP tunnels. The controllers will handle the roaming process altogether. Now, are these mobility controllers where they're built into the access point? May or may not. So again, part of this is going to be that split MAC architecture. As long as both of the APs are involved in a client roaming are bound to the same controller, the controller should be able to update the association as long as the APs are communicating with the wireless LAN controller, and again, through the CAP-WAP tunnel. So again, I'm going to grab my pen. Here, the wireless LAN controller is attached to this switch, and so the wireless LAN controller is what's actually handling the handoff between access point 1 and access point 2. The intra-controller roaming portion is about how efficiently this process can be done. So again, the efficient roaming process is especially important with time-sensitive applications. If you're on a VoIP call and you go from one access point to another, or a teleconference, you shouldn't be losing enough packets to see the video or audio degrade if done properly. So when a roam actually does occur, there could be a brief delay, but it shouldn't be that noticeable. So as long as the time is held to a minimal, then you should be able to migrate between one and another. What are some reassociations that might occur? Sometimes DHCP, and there could be client authentication. The controller might be configured with 802.1x, so that would cause an additional delay. Also, the WAPs or the client could also be programmed to grab a new address through DHCP if they're roaming, and if at the appropriate time, having to request a new address. So these are things that could add in an additional layer of delay. In reality, I've not really seen a lot of companies use 802.1x. Great in theory, but I don't really see it used as often as it should be. Moving on, what about the cryptography key exchange? So again, we're talking client authentication. So there might be a radius portion here. So in addition to the cryptography keys that need to be generated and exchanged, again, that takes time. The Cisco controller offers 3 techniques to streamline the process. Cisco Centralized Key Management, the CCKM, are key caching, and 802.11r. So CCKM is one controller maintains a database of all the clients and keys on behalf of all the access points. Again, putting more load on the controller, but it's nice to be able to have a centralized database, so it does assist with the roaming delay issues. So essentially, if someone does roam between one access and another, the keys are already there. CCKM does require a Cisco-compatible extension support from each of the clients. Again, Cisco is very keen on keeping their proprietary technologies, so that's kind of to be expected. Another area is this key caching. Basically, each client will maintain a list of keys used by prior AP associations and will present them as they roam. Way less secure, but definitely is an option. The destination AP must presented with this list, which is limited to 8 entries essentially. So if this AP was one of the last 8 to be connected to, then the key may be cached. Huge security risk with this, but this is definitely a feasible option. Lastly is an amendment to 802.11 to address fast roaming. Again, that's why it's called 802.11r, and or fast BSS transition. A client will cache a portion of the authentication server key and will present that to future APs while it's roaming. The client will also maintain its QoS parameters as it roams. So here, again, the big thing is being able to roam between access points. Now we're going to move away from an individual access point, might have one wireless LAN controller, and now we're going to actually deal with the centralized controllers. This is when we have 2 or more controllers support APs in the enterprise, and the APs can be distributed among them. So no longer tied to a wireless controller, but multiple wireless LAN controllers. So this brings in a much higher complexity. So this deals with multiple controllers, except when they could also be roaming from the controllers to another, all really depending on how the neighboring APs are assigned to the controllers, how they're load balanced, and how they are dealing with the individual load on each controller. You can't always assume they're going to be load balanced the exact same. One access point attached to one wireless LAN controller might be overutilized, where other ones along the edges of a facility may have a significantly lower utilization or a lower load. So again, you cannot always assume everything is synchronous and load balanced between everything identical. So just keep that in mind. So what does this mean? This means when we're looking at our larger wireless enterprise-based networks and we have multiple wireless LAN controllers, again, the wireless LAN controllers need to be able to sync back and forth. We're going to be using our CAP-WAP tunneling between our APs and our WLCs, but the LAN controllers themselves have to be able to communicate with one another. That's a huge part of this. So when the client roams from one WAP to another WAP, the WAPs themselves on different controllers will actually make the intercontroller roaming portion. So here's a great example. So when the client roams to a different AP, it can try to continue using its existing address or work with whatever services that are out there. So here we are roaming. Let me grab my pen. We are roaming from one network to another. Again, we're assuming these are all one large network. And the SIDs are the same, and the subnets are the same, and the networks are the same. Are these two syncing information? So when client goes from WAP 1 to WAP 2, because the client has roamed between the APs but has stayed on the same network, it should allow for that intercontroller to actually allow for roaming. Again, the controllers should be sharing information. So before a layer 3 intercontroller roam, for example, again, now notice that WAP2 is on a separate VLAN, separate IP scheme. So when the client initiates an intercontrol roam, the two controllers involved can compare VLAN data and other network information that are assigned to them. If the two VLANs differ, again, the controller will arrange a layer 3 roam that allows the client to keep using its IP address while it migrates over. This is what's really interesting, is client 1 keeps its IP address, and the CAPWAP tunnels through the LAN and actually allows us the tunnel between the controller, in this example controller 2, back to controller 1. So it keeps the IP address that it has, even though it's on VLAN 200 in this example. With this network range, it's allowed to keep the same address, but tunnel back through the wireless network through a CAPWAP back to the originating wireless LAN controller. So this is called an ENCOR controller. And the controller with the roaming client is called the foreign controller. So here, ENCOR controller, that's where it originated from. And here will be the foreign controller. So there are ways to scale this properly. Now, this does get a little bit tricky when we are starting to see wireless devices on a network that are not having matching IP addresses. But again, normally at this point, they're not actually on the LAN. They're tunneling between the WAP and the anchor or source controller. So they actually should not be able to be seen on the LAN. So as we progress, controllers can be organized into mobility groups to facilitate this intercontroller roaming a little bit more efficiently. If two centralized controllers are configured correctly to belong to the same mobility group, they can allow for clients to be able to quickly roam between them. However, if the two controllers are assigned to different mobility groups, clients can still roam between them, but not as efficiently. Credentials won't be cached or shared, so clients will have to go through the entire authentication process again, and that typically means session states are also going to fail as well. In this example, we can have a large mobility domain, and within the large mobility domain, we can have different mobility groups that are assigned and grouped. Again, roaming can still occur between the different groups, however, they're going to be less efficient. The mobility list will give a controller its view of the outside world that it knows and it trusts, as well as what's configured within its own group. Each group will maintain a list of its own MAC addresses and the MAC addresses of the other controllers within its group. So let's talk about locating devices in a wireless network. Again, wireless networks are usually designed to provide coverage and connectivity all over the place, but that does mean that our wireless networks need to be able to start seeing where devices are to better provide signaling to those areas. We can look at distance based off of the power. So a client's distance from the AP can be computed from its RSS. If the distance is measured from a single AP, it's difficult to determine where exactly the AP is. However, we can triangulate items so we can see exactly where an item is when we have multiple APs, typically 3, to figure out exactly where an asset is. We also have the ability to look at real-time data tracking when we have multiple APs and you've actually configured the mapping correctly. Again, the most intuitive way to interpret location data is to view devices on a map that's been designed. Normally, when you deploy your wireless networks, you can actually upload maps, place the access points, so that when you're doing the data location, you can get a better, more true, accurate picture of what's going on. So, in the same real-time location services, there also supports the wireless devices that might never actually associate with the APs. You might be interested in locating a potential customer's smartphone as they walk through the location or through the store. RFID tags are another type of device that can be attached to objects so they can be tracked and located as well. Not always looking at a individual technology-based asset like a computer or laptop. It could be other things that have wireless connectivity. So keep that in mind. You can also look at rogue devices that are connecting or being able to pinpoint those devices when you have multiple APs that can see the rogue device, so you can triangulate exactly where that rogue device may be. Again, all of these features are in Cisco wireless products as long as they are set up correctly. Alright, so that is actually the end of this module. We talked about roaming between APs. We looked at inter and intra controller roaming. We looked at layer 2 and layer 3 controlling. We looked at mobility groups. We looked at locating services. We looked at things like mobility domains, mobility groups, foreign controllers, anchoring controllers, roaming. Alright, so that's the end of this chapter. If you have any questions or concerns, feel free to reach out. Thank you. Alright, so that wraps up this module. If you have any questions or concerns, definitely feel free to reach out. Post a comment, ask a question. Remember, as we're going through this material, it's common to be able to take some time, gather your thoughts, ask some questions so that we can really work on retention and getting you more familiar with the material. Thank you.